even sure this first speaker, Jeremy Keaton, needs an introduction, to be honest. Probably a few of his 160,000 Twitter followers are here too, so, but I'll still do so. Jeremy is the founder of ClearLeft. He wrote several books, including HTML5 for web designers, which was published at A Book Apart, and I think was the starting point for a lot of developers to start with HTML5. He's been a speaker at Smashing Conference, Event Apart, Frontiers, South by Southwest, I think everywhere. Also did his share of organizing himself, for example, with Deconstruct. So we're very happy to have him here today to talk about the tag that guides us through the web, the anchor. Please give him a bit of applause.
Thank you. Thank you very much. Good morning. A is for apophenia. Apophenia is the name of that tendency in humans to see patterns where none exist, to draw connections, to make links. Every conspiracy theory is an example of apophenia, but you don't have to be a conspiracy theorist to experience it. We do it all the time. We see shapes in the constellations at night. We see faces in just about everything. And today, I would like to engage the apopheniac in you. Now, in HTML, A is for anchor. Anchor is an odd device to represent a link. I remember seeing anchor symbols used in the interfaces of rich text editors. Right? And if it wasn't an anchor, it would be a chain, right? Because I guess that was meant to represent a link because chains have links. But anyway, why A? Wherefore anchor? Well, it all goes back to how the A element was originally used. And when I say originally, I mean originally. Let's take a look at the very first A element in the very first web page at the very first URL. Now, this looks pretty familiar to us today. There's an A element with opening and closing tags and some text in between. And there's an href attribute for the destination. But there's also a name attribute. Now, this has since been deprecated. Now we can just use an ID attribute on any element. But the idea was that A elements could be used to create destinations for inbound links. They were, if you like, anchors within a page that other pages could tether themselves to. Each anchor is given a unique identifier, unique within the page, that is. Here, the identifier is simply the number 0, because this page was created by a programmer, and in the mind of a programmer, counting begins with 0. Now, this use of the A element, using name attributes to create in-page anchors, it never really took off. But the other attribute, the href attribute, that spread like wildfire. It's short for hypertext reference, and in this particular instance, the reference is to another page in the same directory on the same server. And it's a page about hypertext. Hypertext is text which is not constrained to be linear. So this term was first coined by Ted Nelson. And he didn't just talk about text either. He also talked about hypermedia. He coined lots of interesting words like that. He talked about things being deeply intertwingled. He also coined the term teledildonics, but that is not directly relevant to hypertext or hypermedia. So if hypertext is text which is not constrained to be linear, how did we ever manage with good old-fashioned non-hypertext and non-hypermedia? We used archives. A is for archive. In 1965, J.C.R. Licklider was commissioned to write a report on libraries of the future. He and his company, Bolt, Beranek, and Newman, will prove to be instrumental in creating our modern hypermedia world. More on that later. For now, let's look at this report. It has two parts. 1, concepts and problems of man's interaction with the body of recorded knowledge. And 2, explorations in the use of computers in information storage, organization, and retrieval. I just love the scope of that first part, right? Looking at the body of recorded knowledge. It's interesting that he talks about knowledge, not information, not data, but knowledge. How does data become information? How does information become knowledge? The Library of Babel is a short story by Jorge Luis Borges, who I think of as the poet laureate of hypertext. He imagines this vast library that is filled with data, but frustratingly short on knowledge, because this library contains not only all the books ever written, but all the books that could ever possibly be written, with every possible permutation. Here's how it works. The universe, which others call the library, is composed of an indefinite, perhaps infinite number of hexagonal galleries. The arrangement of the galleries is always the same. 20 bookshelves, 5 to a side, line 4 of the hexagon's 6 sides. Each bookshelf holds 32 books, identical in format. Each book contains 410 pages, each page 40 lines, each line approximately 80 black letters. So let's figure out how many books there are in the Library of Babel. First, we need to know how much data each book holds. There are 80 symbols or letters per line and 40 lines per page, and there are 410 pages in each book. Okay, so multiplying 80 by 40 gives us 3,200, the number of symbols on each page, and you multiply that by 410, we get a total number of 1,312 symbols in each book. We have 2 other pieces of information to work with. Borges tells us the orthographic symbols are 25 in number. That's 22 letters, the comma, the period, and the space. And here's the crucial bit of information that ensures the library has boundaries. In the vast library, there are no 2 identical books. Knowing that, we can calculate the number of books in the library. It's the number of symbols, 25, raised to the power of the number of symbols in each book, 1,312,000. 25 to the power of 1,312,000, expressed in base 10, is 10 to the power of 1,834,097. Remember, that's just the number of books, a figure that's over 1,834,097 digits long. That number wouldn't fit inside one book in the library, which, if you remember, holds 1,312,000. So the number of books in the Library of Babel is not infinite, but it is really, really, really big. To give you some idea how big 10 to the power of 1,834,097 is, it has been calculated that the observable universe contains approximately 10 to the power of 80 atoms. There are more books in the Library of Babel than there are atoms in the universe. And yet, thanks to the World Wide Web, you can theoretically peruse all of them. Jonathan Bazille has created libraryofbabel.info, an online representation of Borges' creation. It contains all possible text. And you can browse by hexagon, then shelf, then row, then book, then page. Or you can search for a specific piece of text because, of course, that text must be in there somewhere. The very words I am speaking now must be somewhere in the library. And there's also a plugin for Chrome, so you can highlight any piece of text on the web and then find its corresponding page in the Library of Babel. So this library has every possible piece of data, but it is sorely lacking in information, although the online version helps. A is for all. Having all the data isn't enough. It needs to be organized, turned into information for us to make use of it, and hopefully further transform it into knowledge. And there have been many attempts to organize information. When those attempts are limited to a subset of data instead of trying to create a Library of Babel, then they can be quite successful. Carl Linnaeus organized the natural world using a naming convention for describing species, binomial nomenclature. Charles Messier cataloged astronomical objects. Melville Dewey created the Dewey Decimal System to help librarians organize their collections. But this was a proprietary system, not an open standard. So the Belgian librarian, Paul Ottelet, devised a universal decimal classification system. I think it's fair to think of him as the father of information architecture. The crazy old uncle of information architecture is Bishop John Wilkins, who in 1668 wrote an essay towards a real character and a philosophical language. And centuries later, this would pique the interest of Borges, who described Wilkins's madcap idea in an essay entitled The Analytical Language of John Wilkins. This idea was that the world could be classified into sounds. He divided the universe in 40 categories, or classes, these being further subdivided into differences, which was then subdivided into species. He assigned to each class a monosyllable of 2 letters, to each difference a consonant, to each species a vowel. For example, de, which means an element; deb, the first of the elements, fire; deba, a part of the element fire, a flame. It didn't scale well. Gottfried Wilhelm von Leibniz, inventor of calculus and nemesis to Newton, had a similar idea to Wilkins around the same time. But whereas Wilkins was trying to classify information using sounds, Leibniz wanted to use symbols, characteristica universalis. His leap of genius was to realize that if you could do this, represent the world using symbols, then you could perform calculations on those symbols. He described the conceptual framework for performing such operations as calculus ratiocinator. And centuries later, Norbert Wiener, the creator of cybernetics, would say the general idea of a computing machine is nothing but a mechanization of Leibniz's calculus ratiocinator. A is for Ada. Leibniz's calculus ratiocinator was an idea rather than a real machine. Charles Babbage, who was a Victorian inventor and entrepreneur, was given seed funding by the British government to create his difference engine, a machine for computing logarithmic tables, a computer, if you will. And the Wozniak to Babbage's Jobs was Ada Lovelace, the daughter of the notorious Lord Byron. Ada's mother did everything in her power to steer her daughter away from following in her father's footsteps of becoming a poet. Instead, Ada immersed herself in the world of mathematics. And it was through mathematics that Ada hit upon the same insight as Leibniz. If we can perform calculations upon symbols, and those symbols don't have to just represent numbers, then we can perform calculations on anything, maybe even poetry. In enabling mechanism to combine together general symbols in successions of unlimited variety and extent, a uniting link is established between the operations of matter and the abstract mental processes of the most abstract branch of mathematical science. The difference engine was abandoned in favor of an even more ambitious project, the analytical engine. Finally, the world would get a mechanical machine capable of performing calculations on symbols that could represent concepts or thoughts, a thinking machine. As with so many startups, Lovelace and Babbage never quite managed to make it to market. But at least they did genuinely have an incredible journey before going broke. A is for Alan. The analytical engine, like the calculus ratiocinator, remained an idea. It will be another century before we get a real nuts and bolts computing machine, thanks to the brilliant Alan Turing. But as well as having a hand in creating the world's first physical computer, he also presented us with an imaginary machine. This theoretical machine was described as having an infinite tape marked out into squares on each of which a symbol could be represented. Now, like Leibniz's calculus ratiocinator, a Turing machine would operate on symbols. So how many symbols are we talking about here? Remember, the Library of Babel had 25 symbols to work with. Two symbols, 1 and 0, on and off, true and false. Because with an infinitely long piece of tape and an infinite amount of time, 2 symbols are enough to calculate literally anything. This reduction of the world into its smallest pieces of information was the brainchild of Claude Shannon, and he coined the term bit to describe this indivisible unit. By the way, Turing himself referred to his theoretical machine as an automatic machine, or a machine. So A is for a machine, but A is also for Atlantic, because there's another imaginary machine that serves as a wonderful conceptual prototype for working with hypertext and hypermedia. In 1945, Vannevar Bush published an article in the Atlantic Monthly called As We May Think. And in this article, Bush describes a machine called the MEMEX, a contraction of memory index. The MEMEX is built into a desk. Screens and switches on the surface of the desk allow the user to interact with huge amounts of information stored within the desk on microfilm. This would provide an enlarged, intimate supplement to one's memory. Because everyone's mind is different, no two people would use the MEMEX in quite the same way. Bush described these individualistic approaches to linking concepts together as associative trails. Wholly new forms of encyclopedias will appear, ready-made with a mesh of associative trails running through them, ready to be dropped into the MEMEX, and they're amplified. So the information stored in the MEMEX is the same for everyone, but the associative trails created by the user in navigating this information are unique. Bush also proposed that these associative trails could be shared. Users of the MEMEX could follow the breadcrumbs left by others. This is hypertext. A is for augmentation. So many ideas about hypertext confined to the imagination. When do we get a working demo? Ladies and gentlemen, on December 9th, 1968, we get the mother of all demos, courtesy of Douglas Engelbart. 6 years previously, he had set out his goals for human-computer interaction in a work entitled Augmenting Human Intellect, a Conceptual Framework. And to achieve this aim of augmenting humanity, he created a working demo of his online system, abbreviated to NLS. Oh, and for this demo, he just happened to invent video conferencing, graphical user interface, the mouse, and he also implemented hypertext.
There's a structural relationship between that content entities that should represent the relationship between the concepts of human thought. All right, we never can do that very well with linear text. So inside the computer, we can represent that quite well. In fact, we can represent information structures in a computer that would generally be far too complex for you to study directly.
With Bush's MEMEX and Engelbart's NLS, concepts could be linked together, turning them from text storage devices into hypertext storage devices. But for hypertext to reveal its true power, we need a network greater than anything seen up to this point. And towards the end of the mother of all demos, we hear the first rumblings of just such a network.
And our forthcoming involvement is this ARPA computer network, the experimental network that's going to come into being in its first form in about a year and end up sometime later with some 20 experimental computers in a network. And they hope to be able to transmit across the country with bandwidths of something like 20 kilobits per second, delay times of less than a tenth of a second, which would be enough so that I could be running a system in Cambridge over the network and getting the same kind of response on a CRT.
A is for ARPA. ARPA stands for the Advanced Research Projects Agency. And this government agency turned to our old friend, J.C.R. Licklider, author of Libraries of the Future. His company, Bolt, Beranek, and Newman, set about designing a communication system that used this newfangled packet switching that Leonard Kleinrock was so excited about. With packet switching, information was broken down into discrete chunks, routed around a network independent of each other, and then reassembled at the destination. At the same time, this idea of packet switching was independently discovered by Paul Baran at the RAND Corporation, who was trying to find a resilient network architecture capable of surviving nuclear attack. The packet switching idea was put to the test with the creation of a new network called the ARPANET. The very first message sent over the ARPANET was at 10:30 p.m. on October 29th, 1969. It was the command log in. The message was sent, and the system crashed after the first two characters. So fittingly then, the real first message sent over this proto-internet was low. But they fixed the bugs, and they kept working on making the system better as it grew bigger. It morphed from being a single network, the ARPANET, into being a network of networks, or internetwork, soon shortened to simply Internet. And for this internet to work, it was essential that all the individual networks communicating to it were using the same protocols to communicate. That's what really makes the internet the internet. Regardless of what kind of hardware is being used, there's an agreement on how to switch these packets around. That's really all a protocol is, an agreement. They're more like treaties than code. Bob Kahn and Vince Cerf were the statesmen crafting the internet's protocols, and John Postel was the diplomat ensuring adoption went smoothly. They wanted a robust network, resilient not to nuclear attack, but to any kind of top-down control. They set out to create a protocol that would work for a network with no center. And together, they crafted TCPIP, the Transmission Control Protocol and Internet Protocol. TCPIP is a deliberately dumb set of protocols. The protocols care not a whit for the contents of the packets being switched around the network. It's a simple low-level agreement. They used to joke that you should be able to implement TCPIP using 2 tin cans and a piece of string. You can then create more complex protocols on top of this simple, low-level, dumb foundation. You can create protocols for sending and receiving email, protocols for Telnet, Gopher, file transfer protocols, all of which sit on top of TCPIP. Best of all, you don't need to ask for permission. If you want to create a new protocol today, you can just go ahead and do it. All you need is rough consensus and running code. And it turns out that running code isn't the hard part. The hard part is convincing people to use your protocol. Otherwise, you don't benefit from Metcalfe's law. Right? The value of a network is proportional to the square of the number of users of the system. Think about it. The first person to own a telephone had a completely useless object. As soon as one other person had a telephone, it suddenly became exponentially more useful. So that was the challenge facing the creator of a new protocol at the start of the 1990s. And that protocol was HTTP, the Hypertext Transfer Protocol. HTTP is one part of a 3-part stack. HTTP is the protocol, URLs are the identifiers, and HTML is the format. And together they form the World Wide Web project. This project was the brainchild of a young computer scientist named Tim Berners-Lee. And this wasn't his first attempt at creating a hypertext system. In the 1980s, he created a system called Enquire. It was named after a Victorian book of manners called Enquire Within Upon Everything, which I always thought would be a great name for the World Wide Web. But Enquire didn't work out in the end. It would influence the design of the World Wide Web project. Another influence on the design of the system was the place where Tim Berners-Lee was working, CERN, the European Centre for Nuclear Research. It's an amazing place. The greatest experiment in the history of our species is being conducted beneath the border between Switzerland and France. In the 16-mile-wide ring of the Large Hadron Collider at CERN, human beings are recreating the conditions from the start of the universe. Protons are smashed together at velocities approaching the speed of light. It is a truly awe-inspiring endeavor. When I visited CERN, I expected to be blown away by the science, and I was. And I expected to be blown away by simply being at the birthplace of the web, and I was. But what I wasn't expecting was to be blown away by how things get done at CERN. There is very little hierarchy. People from all kinds of backgrounds, from Nobel Prize-winning physicists to students on a summer internship, collaborate on experiments for pure scientific research. And trying to manage the flow of information in this collaborative but chaotic place was the challenge that Tim Berners-Lee was trying to solve. You can't just mandate a particular operating system or piece of software. People at CERN can and will use whatever they want. In the same way that the internet is a network of networks, what CERN needed was some way of allowing all these different computers with different operating systems to share information with each other. So Tim Berners-Lee submitted a paper to his supervisor, Mike Sindel. It had the uninspiring title, Information Management, a Proposal. Well, Mike Sindel must have seen some potential because he scrawled across the top, vague but exciting. And the proposal described a solution based on a distributed hypertext system. Tim Berners-Lee was very familiar with previous hypertext systems. All of these fed into his project. Vannevar Bush's Memex, Douglas Engelbart's online system, Ted Nelson's Xanadu, although it was still vaporware at this point, Apple's HyperCard system for the Mac, and his own Enquire project. But just creating the code wasn't enough. He and his colleague and collaborator, Robert Cailliau, needed to convince the scientists at CERN to use this technology. To start with, they needed a catchy name. For a while, they floated the idea of calling it the mesh. Then they kicked around the idea of calling it the information mine. But Tim Berners-Lee wasn't keen on this one. He knew that whatever name they chose, it would end up getting abbreviated, and he was worried this would look a little egotistical. So they settled on World Wide Web. And you've got to admire the chutzpah of calling it World Wide Web, when at that point it only existed on one person's computer. And sure enough, it did end up getting abbreviated. Except in this case, there are actually more syllables in the so-called abbreviation, www, than there are in the full name. They even made a logo. Graphic designers, they are not. But there is a reason for the green color of the W's. Robert Cailliau is a synesthesiac. He hears the W sound as the color green. And so the web was born. Good job. Learning from the lessons of TCPIP, Tim Berners-Lee made sure to keep the individual parts of the system as simple as possible, but no simpler. The World Wide Web didn't succeed because the technology was the best, far from it. It succeeded because the technology was just simple enough, but also powerful enough for people to get started with it straight away. Take HTML, for example. There was no official version 1 specification for this hypertext markup language. Instead, there was a document called simply HTML tags, presumably written by Tim Berners-Lee. And this document listed the entirety of HTML, which is a grand total of 21 elements. And most of those elements weren't invented by Tim Berners-Lee. Instead, he borrowed the vocabulary already being used by scientists at CERN. They were used to writing documents in GML, which is supposed to stand for Generalized Markup Language, but was coincidentally created by 3 people whose last names were Goldfarb, Mosher, and Laurie. There was one element that was completely new to HTML. A. This one single element is what enables the HT part of HTML. With this element and its href attribute, anyone could link to anything on the web. It is brilliant in its simplicity. So, pleased with the way that project was going, Tim Berners-Lee and Robert Cailliau submitted a proposal to present their World Wide Web at a hypertext conference. They were rejected. Hypertext experts thought the World Wide Web was stupid. As Ted Nelson put it, today's one-way hypertext, the World Wide Web, is far too shallow. The Xanadu project foresaw worldwide hypertext decades ago and endeavored to create a much deeper system. The web, however, took over with a very shallow structure. He's not wrong. Hypertext on the web is shallow. It is stupid. Like TCPIP, it is not smart. The thing is, if you're hoping to get mass adoption, being smart is a bug. Being stupid is a feature. Just about every other hypertext system embodied the idea of two-way linking. There was an awareness at both ends of the link. If the resource being linked to were to move or change, the link would be updated. It's robust, but it's complicated. On the World Wide Web, by contrast, links only work in one direction. If the resource being linked to ends up moving or changing, well, tough luck. The result is link rot. And that's the price we pay for a simple hypertext system. But now that the web's been around for a couple of decades, there is a sorta, kinda implementation of two-way linking. It uses the humble rel attribute. Rel, short for relationship. The value inside the rel attribute describes the relationship of the linked resource to the current document. Some rel values were officially canonized in HTML. Rel equals prev means that the linked resource has the relationship of being the previous document to the current document. Rel equals next means that the linked resource has the relationship of being the next document after the current document. Rel equals author means that the linked resource has the relationship of representing the author of the current document. You get the idea. Incidentally, there was once a corresponding rev attribute that described the reverse relationship. That is, the relationship of the current document to the linked resource. So you could simultaneously say that the current document has a relationship of being the previous document to the linked resource, and that the linked resource has a relationship of being the next document to the current document. Confused? Well, that's why the rev attribute was eventually dropped from HTML. It was too complicated. There was an attempt to use the rev attribute in an early micro format called vote links. This was proposed way back in 2004. Blogs were hot. Political blogs were really hot. Bush Jr., no relation to Vannevar, was running for re-election in the States. John Kerry was the challenger, and there was much blogging and gnashing of teeth. And the problem was the rise of PageRank, the algorithm that drove Google's search engine. The fundamental premise of PageRank was that linking to something counts as an endorsement, but there were many bloggers linking to articles that they disagreed with very strongly. By using a rev value of vote for, authors could explicitly say that this document is a vote for the resource being linked to. Or by using the rev value of vote against, they could make it clear that this document is a vote against the linked resource. It never really took off because, as I said, the rev attribute was just too hard to grok. And that's okay. The whole point of microformats is that they are the very embodiment of the motto of the Internet Engineering Task Force, rough consensus and running code. There just wasn't enough take-up of vote links for it to thrive. Another early idea that actually preceded the official creation of microformats was XFN, which stood for XHTML Friends Network, the most Web 1.0 format name ever. XFN built on existing behavior. Bloggers would often have a list of links in their sidebar pointing to other bloggers they had some kind of relationship with. If you assume that a URL can represent a person, then the rel attribute is perfect for encoding that relationship information. I can link to a friend's website and say that the person represented by the linked resource has a relationship of being a friend to the person represented by the current resource, me. Or I can link to a colleague's website and say that they have a relationship of being a colleague to me. And because rel values, like class values, can be space separated, I can combine rel values into one attribute. I can link to somebody and say that they are both a friend and a colleague. I still have XFN values in the sidebar of my blog, but again, it never really took off. Except for one value that at first glance seems to be completely pointless. A rel value of me. The linked resource has a relationship of being me. A is for Adactio. My website is adactio.com. I love my website. Even though it isn't a physical thing, I think it might be my most prized possession. It's a place for me to think and a place for me to link. But my web presence isn't limited to adactio.com. I have profiles on lots of different sites. Twitter, Facebook, Instagram, Medium, Dribble, Flickr, Tumblr, CodePen, the list goes on. Now, none of these places are as important to me as my own website, but they are representations of me. And I link out to these profiles from my own website using that rel value of me. That's me on Twitter. That's me on GitHub. That's me on Flickr. Nothing unusual there. These are regular one-way hyperlinks. What's interesting is that many of those profiles on other websites provide a URL field where I can enter my own website. And those third-party profiles then link back to my website, also using a rel value of me. They also use a rel value of nofollow to discourage spammers. The phrase nofollow makes absolutely no sense as a rel value. You can't have a relationship of nofollow to anything, but it was invented by Google, and we don't get to argue with the 900-pound Google gorilla. Anyway, the result of having these reciprocal links, both using rel equals me, means that we kinda, sorta, got two-way linking on the World Wide Web. But, so what? A is for authentication. Some of those third-party profiles I'm linking to, Twitter, GitHub, Flickr, have something in common. They allow third-party authentication using OAuth. If I can log in to my Twitter or GitHub or Flickr profile using OAuth, and those profiles have two-way links with my website, then I can borrow that authentication flow from my own site. That's the idea behind IndieAuth. I enter the URL of my own website, it finds the links from there to my other profiles using rel equals me, then I can choose which one of those profiles I want to authenticate against. Once I've authenticated with that service, I've also authenticated with my own website. Just by adding a short rel value to some links, I can use my website as a login. My website also has a small write API. The API is called MicroPub. By combining IndieAuth and MicroPub, I can log into somebody else's posting interface using my website, and then use that interface to post to my website. So these building blocks, microformats, and IndieAuth and MicroPub, have emerged from a small but dedicated group of people. And we gathered together at fun little events called Indiewebcamps. An Indiewebcamp takes place over 2 days. The first day is split into discussions of technology and design. And the second is all about implementing what we've discussed on the first day. I'm always amazed by how much gets done when you're in the same space as like-minded people. But still, the technologies being discussed and implemented aren't the real focus of Indiewebcamp. The core tenet of Indiewebcamp is an idea, and it's a very simple idea, one that at one point would not have been controversial. And that idea is that you should have your own website. But who's got time for that? Especially when it's so much easier to write and share and link using platforms like Twitter, Facebook, Medium. And that's a good point. A lot of the time at Indiewebcamp is spent reverse engineering what those services are doing so well and applying them to personal websites. Also, we don't necessarily want to stop using those services. After all, that's where the people are, for now. Instead, we want to figure out ways of making use of these services while still keeping the canonical versions of what we create under our own control. There's a fantastic little indie web service called Bridgie that allows you to not only post from your own site out to third-party networks, but also receive replies, and likes, and retweets back at your own site using another indie web building block called web mention. In a way, web mentions allow a kind of two-way linking. I can cross-post something from adactio.com to Twitter, Instagram, or Facebook, and then when someone replies on Twitter or Instagram or Facebook, I get notified with a ping back to my own site. And all of this is possible because I've verified the identity of those third-party profiles using nothing more than a simple rel attribute on a hyperlink. The IndieWeb uses a grab bag of deliberately simple technologies that combine to create something so much more powerful than the sum of its parts, just like the web itself. We often talk about places like Facebook or Instagram or Medium as walled gardens. Walled gardens are as old as the web itself. AOL was a very well-cultivated walled garden back in the day. And there's nothing wrong with walled gardens. They're safe spaces. They take care of your enjoyment and entertainment so you don't have to. But they're also a bit boring. I don't relish the idea of spending my days within the boundaries of somebody else's vision. There's a different kind of garden, and it takes its name from another short story by Borges, The Garden of Forking Paths. It is uncontrolled. It is full of possibilities. It's a bit scary. It takes more dedication to explore. You might get lost, but is that so bad? When was the last time you were truly lost on the World Wide Web? When you clicked through link after link, no cheating by opening new tabs now, until you ended up somewhere blinking and asking yourself, what was I looking for? I would like us all to spend more time in the garden of forking paths. I would like us all to continue to grow this garden of forking paths. Add your own website to this garden of forking paths. Use it to make more links. On your website, you can link to this thing over here and that thing over there, and in doing so, create an entirely new forking path. Remember, the web, like the internet, has no center. In theory, I could start from any single A element, and by following all the forking paths, traverse the entire World Wide Web. And that opening hyperlink could be on your website. One single A element can be the portal to an entire universe of knowledge. Thank you all.
Some books and publications, so brings up nearly the question, can we expect a history book?
I seem to have accidentally written a book that's sort of about, the history of the web. And I'm thinking about ways to publish that. I might do the self-publishing thing, and there will, of course, be a hypertext version. But,
I wouldn't be surprised if there is a lot of interest for it, especially if you bring up the examples already back to Ada Lovelace and Engelbart, up to ARPA. It is a rich history which all mentions the concept of the link, and I think that's refreshing for everyone to see how fundamental that is for the stuff we're doing every day.
There is a book by Alex Wright, who used to be information architect at the New York Times. It's called Glut, and it's basically a look at the alternate hypertext systems, the ones that didn't make it. And maybe why they didn't make it, and why did the web succeed.
Okay.
So that's definitely worth a read. Yeah. My takeaway from it is that the web succeeded because of its simplicity.
That's right.
And that in general you want to go for simple if you're looking for mass adoption.
Yeah, and when you were talking about links, you also mentioned, for example, microformats, and if I believe you had some share in developing it?
Yeah, and microformats are still going. Some people might find that hard to believe, but the focus has changed. See, it used to be the idea with microformats was we'd encode very, very common patterns that weren't already covered by HTML. So HTML doesn't have a person element, and it doesn't have a place element or an event element. So let's use class attributes to encode that stuff. But the thinking back then was that, well, if enough people do this, that we get a network effect, that it enables kind of a semantic web of gluing stuff together. But it relied on a lot of people doing it. The focus has changed now, personally, because I still use microformats, but my focus is not hoping that anybody else will necessarily use it. It's just on my own website, it actually enables a lot of value for me. So a lot of these building blocks like web mention and this stuff, if you've marked up your website using these microformats, it makes it easier for these technologies to parse that stuff. So the focus has changed from microformats to something we're hoping everyone's going to do to being actually focused just on one person, and that's yourself.
Right. And could we maybe see like microformats and maybe sometimes open graph kind of stuff as maybe adding some functionality to stuff that's not in the basic spec of HTML?
Right, and then there's been various attempts at this, right? RDFA and microdata in HTML. And then Google and Yandex came along and said, no, we're all using schema.org. Just like the Nofollow thing. They said, no discussion. This is the way it's going to be.
Yeah.
They came down from the mountain with schema.org inscribed on tablets and said, this is what you will now use.
Yeah.
And so we use schema.org these days, which is very different to microformats, because the idea of microformats, in terms of vocabulary, microformats is very, very limited. Like I said, just a few things, events, people, that was it.
Yeah,
Where
right.
schema.org is trying to cover everything. Like, for example, in schema.org, your volcano can have a fax number.
Yeah, right.
So,
and there's a lot of, there's quite a lot of development also in schemes, so you constantly have to stay updated about it? Is that right about
there's validators, and you run your stuff through the validator one day and it's fine. You run it through the validator later and it says no.
Right.
People can't have logos was something that I was told recently on the validator. So, pretty sure they can.
I got the idea from your talk, like that we're somehow, and maybe this is part of it, is how stuff like schema is changing, and that we're losing sometimes our archive, our library, where you were talking about. Am I right to judge that?
Yeah. Digital preservation is a big problem on the web. But it's not actually a problem of technology, because we have the technology to keep things online. It's a matter of will, and it's also a matter of perception, because the problem is that most people believe this myth that the internet never forgets. That, you have to be really careful what you put online, because once it's up there, it'll be up there forever. I mean, that would be great. Like my backup system would be taken care of if all I had to do was put something online and then it's magically never going to disappear. The problem is the exact opposite.
Yeah.
If you put something online, over a long enough time period, it will disappear, guaranteed. It's not a matter of if, it's a matter of when.
There are all civilizations where we don't know our history because at one point all the books were burned.
Exactly.
Is that
And
what's happening?
Very much so. And the Library of Alexandria, is famous for what we don't know about it.
Right.
And that's the direct inspiration for the Internet Archive that Brewster Kahle has set up, which is a wonderful organization. He's kind of like the Bruce Wayne of the web, right? Because he's like this rich dude who made his money in the early days, but instead of squandering it, he decided to create this fantastic archive.
Yeah.
But it's tricky because even when you've got as much of the web backed up on the Internet Archive as possible, it's still at different URLs, right?
Yeah.
So anything that was linking to that original thing, we've lost that link because we do have simple one-way linking.
And we
on the
still
web.
depend on just one source.
Yes, and it's centralization is a problem. Most of the best things about the internet and the web have come from decentralization. There's still a few aspects of the technologies that are centralized, and they're a little worrying. Like the DNS system is still under ICANN's control, one organization, and I think they're doing an okay job, but it's still a bit worrying when anything on this network we're working with is centralized.
Right. And do you think these platforms, Medium and stuff, but also URL shorteners and apps, are they the ones that are causing it, or are they also part of the solution?
I mean, it may be inevitable. Like I said, we had AOL back in the day. Like it isn't anything new to have these big players. Friendster was huge when it was around. Yahoo was really big. But I don't think it's inevitable that there necessarily needs to be one big player in any one field. Like we look around now and we think, oh, inevitably Google won search and inevitably Facebook won social networking.
Yeah.
But I don't think it was inevitable that there necessarily be one winner. I think the web's big enough to have lots of small, medium, and large players.
Right.
What's interesting now is that all of these different services are kind of trying to do everything. Bruce Sterling refers to them as the stacks because they will do your email and they will do your messaging and they will do your calendars and they'll do your storage. And they're trying to, become indispensable in your life, whether that's Apple or Facebook or Amazon or Google.
So lock in.
Yeah, effectively by doing everything for you. And that's why this idea of the Indieweb, which is a very small, simple idea, is actually, to use a term from Silicon Valley, is actually quite disruptive because on today's web, there's nothing more disruptive than using your own website instead of using one of the stacks.
Right.
And making your own links instead of links being controlled, like I said, through URL shorteners, Facebook or Twitter. Yeah.
Right. I saw a sign that we're out of time, so I want to thank you a lot. I want a really big applause for a great talk by Jeremy Keith. Thank you.
Thank you.
Thank you.